you head to the left, product goes back to reactant. And if indeed the same, we are at equilibrium. If we have an equilibrium concentration and a Kc, we can solve for missing concentration for our reaction. This is just algebra, plug and chug again, so let's take a peek. This isn't so bad. Here's what we know. We have an equation, 2COF2 in equilibrium with CO2 and CF4. This is not an ice chart, and I know that because it's saying it's at equilibrium, so it's like filling in the bottom row of an ice chart, already at equilibrium. We have 0.255 molar of COF2. We have 0.118 molar of CF4. And we have a Kc of 2. What is the equilibrium concentration for the carbon dioxide? Well, the equilibrium expression is taking the products, each of those coefficients are 1s, set over the reactant squared. We know the K. We know 2 of the 3 ingredients. We're going to pull out the missing one. So 2.00 is equal to my variable, carbon dioxide, times the concentration, 0.118, products here multiplied, set over 0.255 molar. What's the missing concentration? Straight algebra. We'll cross multiply and divide. So hitting for carbon dioxide at equilibrium, 2.00 times 0.255 over 0.118. Cross multiply, divide, isolates carbon dioxide. 2 times 0.255 divided by 0.118. In this concentration at equilibrium, 4.32 molar units. Oh, I forgot to square. Darn it. Thanks for checking. Thank you. I heard you guys talking in my head. Square that one. That's my mistake. Coefficient of 2 tells me I have to square that bottom number. Back to the drawing board. Thank you, calculator buddies. 2 times 0.255 squared divided by 0.118. And how about an answer closer to what they got? 1.1. All right, that's a match. And again, that would be big M molarity units on the carbon dioxide. A sample of phosphorus pentachloride is placed in a 0.5 liter container heated to 160 degrees Celsius. The PCl5 is decomposed into PCl3 and chlorine. At equilibrium, 0.203 moles of the phosphorus trichloride and the chlorine are formed. Determine if the equilibrium concentration of PCl5, provided the Kc value is given as well. So our chart is not an ice chart because it's asking already for equilibrium. 2 of those are provided. In this question, it really isn't any more difficult than the previous one, except they're making us work out big M, molarity. Molarity is moles per liter. They gave us moles and they gave us liter. So they're just making us hit for the molarity. 0.203 moles set over 0.5 liters is probably 0.406, but I'll prove it to myself. 0.406. So moles per liter is big M. Molarity units are what those brackets stand for. Alrighty. So we know Kc to be 0.0635. We know the concentration in molarity units to be 0.406. I'll square that since we're multiplying it by itself. We'd like to know PCl5, so there's your variable x. These two switch places. X is found by 0.406 squared over 0.0635, and there's our concentration in big M, molarity units.